In some respects, Neptune's existence seems almost improbable, or at least its position is unexpectedly unique. The James Webb Space Telescope has transmitted a breathtaking new image of Neptune, showcasing the icy giant in unprecedented detail, the clearest we've seen in 3 decades. But this isn't merely an aesthetically pleasing snapshot. Neptune, along with its counterpart Uranus, is composed predominantly of ice and frozen gases like methane, ammonia, and water, defining its structure. This fresh perspective reveals more about the planet beneath its striking blue exterior, a hue driven by methane in its atmosphere. As one of the least explored planets in our solar system, Neptune offers a wealth of mysteries. Given its distant orbit, interactions between celestial bodies in this region happen over extended timescales, making collisions rare and slow to occur. The recent observations from the James Webb Space Telescope, JWST, offer insights into Neptune that were previously unavailable. For over 30 years, the Voyager 2 spacecraft provided the best view of Neptune, having been launched in 1977 to explore the solar system and eventually venture into interstellar space. Although the Hubble Space Telescope also contributed some observations, it wasn't until JWST's launch in 2021 that the scientific community received a significant upgrade in clarity. By September 2022, JWST provided the most detailed images of Neptune's rings in 3 decades and offered a fresh look at the planet itself. Captured by the near-infrared camera, NIRCam, these images reveal Neptune in a new light, quite literally, as the planet appears darker due to methane absorbing red and infrared light. This is in contrast to Jupiter and Saturn, which are less influenced by methane. Neptune's atmosphere, richer in heavier elements than Jupiter and Saturn, shows bright bands and spots in the images. These are high-altitude methane ice clouds reflecting sunlight. JWST's superior resolution has allowed for the first detailed view of Neptune's ring system, suspected to be composed of ice crystals. Additionally, the image reveals a thin, bright line encircling Neptune's equator, indicative of intense atmospheric activity like winds and storms. It also shows a clearer depiction of a known vortex at the South Pole and a continuous band of clouds at higher latitudes, a significant advancement in understanding Neptune's atmospheric dynamics. JWST's findings represent a major milestone in Neptune research, especially given the lack of a dedicated Neptune probe mission. The data unveil new details about Neptune's rings, atmosphere, and weather systems. Neptune, the 8th planet from the Sun, is located about 2.8 billion miles away, over 30 times the distance from Earth to the Sun. It is the 4th largest planet and the 3rd most massive, with a mass about 17 times that of Earth, slightly more than Uranus. Its icy composition earns it the designation of an ice giant, primarily made up of gases, liquids, and ice. Neptune was first detected as a blue blur by Galileo Galilei in the 17th century, who initially mistook it for a star. It wasn't until 1846 that British mathematician John Couch Adams and French astronomer Urbain Le Verrier independently predicted the existence of Neptune, with German astronomer Johann Gottfried Galle confirming it. The planet's vivid blue color, due to methane gas in its atmosphere, has inspired its namesake, the Roman god of the sea. Despite its beauty, Neptune remains one of the least explored planets, with significant atmospheric changes noted over recent decades. Voyager 2, in 1989, observed a massive storm known as the Great Dark Spot, but by 1994, this spot had vanished, replaced by a new one. Hubble's observations revealed that Neptune's storms, unlike Jupiter's persistent Great Red Spot, are shorter-lived but extremely intense. The planet's wind speeds can reach 1,350 miles per hour, far exceeding the strongest hurricanes on Earth. In 2018, a massive storm on Neptune defied expectations by moving southward, contrary to the typical behavior expected due to the Coriolis effect. This storm, which later reversed direction in 2020, surprised scientists and highlighted Neptune's unpredictable atmospheric patterns. Some theorize that storms may disappear into deeper layers of the atmosphere before reappearing. The recent discovery of a smaller storm, possibly shed from the larger one, adds to the intrigue. Triton, Neptune's largest moon, also captured attention in JWST's images. It is notable for its greenish hue, a result of frozen nitrogen reflecting sunlight. Triton's smooth, icy surface and retrograde orbit suggest it might have been captured from the Kuiper belt rather than forming alongside Neptune. Its potential for ice volcanism makes it a prime candidate for future exploration. The James Webb Space Telescope's remarkable images of Neptune and its moons are providing valuable new insights into the icy giant and its intriguing features, hinting at both past dramatic events and ongoing mysteries in this distant corner of our solar system. Neptune, the distant ice giant of our solar system, has remained one of the most mysterious and least explored planets. Yet, with the advent of new technology and advancements in space exploration, our understanding of this fascinating world is expanding, primarily through the remarkable images and data sent back by the James Webb Space Telescope, JWST. For over 30 years, our best glimpse of Neptune came from a single image captured by Voyager 2 during its historic flyby in 1989. While the Voyager 2 mission gave us our first up-close look at the planet and its intriguing features, it was primarily designed to explore the broader solar system and eventually venture into interstellar space. This left Neptune largely uncharted, especially when it came to the finer details of its atmosphere, rings, and moon system. Subsequent images from the Hubble Space Telescope, while useful, failed to satisfy the scientific community's thirst for more comprehensive data. This all changed with the launch of the James Webb Space Telescope in 2021. Equipped with superior imaging capabilities, the JWST offered a new lens through which to view Neptune, capturing breathtaking images of the ice giant in unprecedented detail. These new images revealed Neptune's rings, which hadn't been seen in such clarity since the Voyager 2 flyby. The rings themselves are composed of ice particles and dust, appearing faint and elusive to previous instruments. With NIRCam, near-infrared camera, scientists were able to view Neptune not only in greater clarity but also in a completely new light. In the near-infrared wavelengths, Neptune appears strikingly dark, a stark contrast to its familiar blue hue, which we typically associate with its methane-rich atmosphere. This darkness is attributed to methane gas absorbing red and infrared light, leaving the planet looking much different than expected. One of the key discoveries made by the JWST was the presence of bright, high-altitude methane clouds that appear almost white against the dark backdrop of Neptune's atmosphere. These clouds, composed of methane ice, reflect sunlight and offer a glimpse into the planet's dynamic and rapidly changing weather systems. The ability to observe these cloud formations provides scientists with vital clues about the meteorological processes occurring deep within Neptune's thick atmosphere. These clouds often appear in bands around Neptune's southern pole and equator, where storm systems rage across the planet's surface, driven by its intense and volatile weather. One of the most compelling features captured by the JWST was a vortex at Neptune's south pole, a giant storm system swirling across the icy planet. This vortex was observed by the Hubble Space Telescope as well, but the JWST allowed for a much clearer view, showing intricate details of the storm and its surrounding bands of clouds. This phenomenon is reminiscent of the Great Dark Spot, a massive storm first observed by Voyager 2 in 1989. Similar to Jupiter's Great Red Spot, Neptune's Great Dark Spot was a colossal storm system, but unlike Jupiter's long-lived storm, the Great Dark Spot on Neptune vanished just a few years after its discovery. In 1994, scientists using the Hubble Space Telescope were surprised to find that the storm had disappeared entirely,